cow problem. Now, the easy part of this one is, I mean, we can find the area of a circle. That's pretty easy to do, right? And since this here is just simply 3/4 of the, that isn't a difficult thing to do, is it? Okay. The part that is difficult comes in right here. Okay. Now, if we consider that the line that's cutting up through here kind of cuts this wedge in half, right? So what we see down here is the same thing that should be up there. Okay. Now, the other part of it is there's two distinct things. What happens if the old bossy runs up over here? Okay, and it's sitting at this point here. That's 10 feet. So now how long is the radius that it can go from that corner being swept around? Well, the rope was 100 feet, right? And so now 10 feet are cut off. So now there's only 90 left here, right? And then 90 would be sitting up over here. The other thing, and mind you, when I'm going through and doing problems like this, I'm just trying to find out all of the values that I can. So what happens is that poor old bossy runs up over here and the rope gets caught again on the corner. Okay? How much rope is left now? Well, no, 90 was up over to here. Bossy walked over here, got caught on the corner here, so now there is only 80 feet left for this thing. Okay? Now, mind you, I just talking about the length of the rope. Now, this turns out to be a triangle in here. Here we've got a nice sector because it's going to be goes all the way around. Not a problem with that. So, if I take a look now for the angles, okay, the angle that would be sitting in here is going to be 90 degrees, correct? The angle that is sitting down in here is going to be 45 degrees. The reason being is that if you're looking at this line going through here, that's parallel, cutting it a square in half gets you a 45-degree angle, so you've got a 45-degree angle there. Okay. Now, because we know we got a 45-degree angle there, we've got 90 up over here. We've got the law of sines kicking in now so that we can figure out what either this angle up here is or that angle up over here is. Now, another thing that we've got is I missed one side identifying one of the sides. Remember, this barn over here is 10. So we know all of the lengths of the sides going around on this. Now, we're actually talking about area, right? So what do we need for the formula for the area of the triangle? Yeah, we need two sides, and we got to have which angle? Okay, so give me the formula for the area then.
1/2 times AB sine.
1/2 multiplied by AB sine of C, right? Okay, so what happens if we know that this is a 45-degree angle there, so we call this C. A and B would be 80 and 10, correct? So when you're looking at the area of that triangle now, that's just going to be 1/2 multiplied by A and B, which would be 10 and 80, and then it's going to be the sine of 45 degrees. Okay? Does that make sense? So that sets up the area for this triangle here. Now, you've got your sector area down here. That's about the only thing that we need to try and figure out. What would this angle in here turn out to be? Okay. So in order to figure that one out, we know that's 45. We know what's going on in here. Again, we would go back to the law of sines and try and figure out one of these missing angles. And the angle that you'd probably want to do would be the one that sets up for 45 and 90, 80 over this angle here. Does that make sense to you? Because once I know what this angle is here, then I can subtract that from 90 and find out what this angle is over here. Okay? Does that make sense?
Yeah. And then you do the area of the sector.
And then you do the area of the sector here, you can do the area of the sector down here, and then you end up getting your total once you add those three things together. So are there any other questions on this one that somebody wants to ask or look at? No other thoughts?